Sir,
Yes, please.
I think his question is in the line, if we had -1 times -1 squared, would this still be
Sorry,
1?
try to speak up. I can hardly hear you.
Okay.
Yes, sir.
Yes.
My question is, sir, or rather, following on this question, here where it says y -y squared, if we had -1, would it still be 1 squared?
So what is -y squared? For instance, this. So I want to maybe show you in a different way, if that is okay. So we have -y squared. What is this? Is this not -1 squared times y squared? You agree? Yes, Lukundo?
Yes, sir.
Yes, so this is then now y squared, isn't it?
Yes.
Yeah, so that's simply what I am doing. If you have y to the power -5, then it is just -1 to the power 5 and the y to the power 5, which gives us the -y to the power 5. Okay, any other question? Right, so next we can actually, yes, Abraham? Abraham, your hand is up and I can't hear you, your mic is muted.
Yes, sir. Like on the final answer where it is plus -y to the power 5. Is it not supposed to be -5y as the final answer?
Oh, yes. So this plus is not supposed to be there, of course. Okay, any other question? Right, so I want to change the power for this one. Yeah. So you can see that this will cut in a few minutes, but we cannot always use the same link to join again so that we can continue. Do you have another class after this one? No?
Yes.
Okay, so if you don't have another class, we can get maybe the next 20 or so minutes so that we can be done. Right, so I was saying I want to change the power of this because power 5 we have 4 to the power 4. So for us to be able to solve this, we have x squared. We just check why give me a different thing. So that's x squared 1 minus 1 to the. So again, if you go to Pascal's triangle, what we have for power 4, we have the following coefficients. So you have 1, 4, next is 6, 4, 1. So again, here, our A is going to be x squared y minus 1, rather x squared y, and our B is The first term, of course, will have a coefficient equal to 1, which is this term, which is a raised to power 4. So I'll just write it as follows. So we have x squared y minus 1 to the power 4. This will be equal to x squared y to the power 4. The next term has coefficient 4. And then you have x squared y to the power 3 times negative 1. And then the next is the coefficient number 6, x squared y to the power 2, negative 1 squared. And the next is 4, x squared y times negative 1 to the power 3. And the last is negative 1 to the power 4. Yeah, so again, your duty here is just to be able to expand and simplify if it is possible. So going ahead in expansion, we have the following. So here you have x to the power 2 times y to the power 4. So what you are going to get here is x to the power 8, y to the power 4. Then we move to the next, you have 4 times the x to the power 6, y power 3, times negative 1. So because of that negative, here our sign changes to negative. So that would be negative 4 x to the power 6, y to the power 3. The next term, you have negative 1 squared is just 1. So that gives us 6 x to the power 4, y to the power 2. And then the next term, you can see that this negative 1 is raised to the odd power, so it will be negative. So our sign there is negative, and you have 4x squared y, and the last term is 1. Then, if there are no like terms, in this case, we just leave it the way it is. So that's the expansion that we get. Is there any question? Right, so there is no question, then we can try to quickly do the last one in the next few minutes. We have 1 plus root 2 to the power 6. So again, if to Pascal's triangle, hope we did power 6. 1, 1. So in this case, we can use the following. See if we can find some like terms. So 6 root 2 plus 30 plus 40 root 2 plus 60, and then this gives us 24 root 2, and then you have 2 to the power 3, which is 8. So now, if we just collect like terms, you have 1 plus 30 plus 60 plus 8. So those are like terms. So you have 60 plus 30, that's 90. So you have 98 and 99. So you have 99, and then plus those with the roots. So you have 6, root 2, 40, root 2, and 24. So 24 plus the 6, that's 30. And then 30 plus 40 gives us, so that gives us 20. Right, so this is how we can use Pascal's triangle for us to expand particular expansion. Is there any question?
I truly love Priya. One day she's going to be my wife.
You're 18. You know the first thing about love. I've said it before, and I will say it again. You do not marry to help daughter.
Right, so now you can see that if you have to expand expressions with power 100, you have a lot of work to do. Yes, Timothy?
From now on,
You can unmute yourself and ask your question.
Mom, I swear to God, if you make her leave, then I'm gone too.
We can't hear you, Timothy, if you are speaking.
Okay, sir. I just want to find out, like, we have been given the binomial to be maybe x minus y to the power that from 1, then we are just following the order up to 8, or maybe there is a way of doing that.
Well, if you are using Pascal's triangle, yes, you have to follow. You have to get the coefficients for up to power 8. Then that's when you can do it. So like I said earlier, this is the tedious process as power increases. So we want to find another way in which we could do this expansion. So remember, we're just talking about Pascal's triangle. Next, we want to see what is known as the binomial theorem. So the binomial theorem gives us another way of expanding such things or looking for particular terms in an expansion. Does that help you, Timothy?
Yes, sir.
Okay, so let's move then to the next thing that we want to look at. So we have what is known as factorial. So we have what is known as so a factorial is just some kind of a product. It's a product we have a way in which to write a certain product. So, for instance, we have this product. So we have 1 times 2 times 3 times 4 and so forth. Let's say times the 98, 99 times 100. So you can see that if we are to write this using all the expressions that are there or the terms that are there, you can see I've put dots because, of course, I'm not able to write. I can write them, but it takes a bit of time for me to be able to write. So for us, what we do in this case, we introduce what is known as a factorial. So this number, we just write it, sorry, this is 100. So this is going to be equal to 100 with that exclamation mark. So, and we read this as 100 factorial. Okay, so whenever we see this, we know that this is the multiplication of 100, or rather from 1 to 100 of all the numbers that are there. So when we write n factorial, for instance, then what we mean is that we are multiplying these numbers. So n factorial will be n times n minus 1 times n minus 2 times and so forth. Then we have 3 times 2 times 1. So n factorial, this is how we are going to express it. Of course, in the same way as this has been done, but of course the order here doesn't matter because you know that multiplication doesn't necessarily restrict to the order. So this is also the same as 1 times 2 times 3 times n minus 2 times n minus 1 times n. So n factorial is this expression that I have written here. So we can also rewrite this in a different form. Since multiplication, of course, is commutative, we can write it in another way. So we know that, for instance, if we have, I just want to write it here. If you have 3 factorial, this is just the 3 times 2 times. Right, so instead of us sometimes writing all the expressions when we think of a factorial, we can write this as follows. For instance, this can also be written as n times n minus 1 times n minus 2.
The world's biggest e-commerce CEO, Marcus Sinclair, is coming to inspect the factory.
You are
Just
disturbing
imagine
me,
if a guy like that noticed.
Right, so someone is disturbing me. All right, so times n minus 3 factorial. So instead of writing all the expression all the way to 1, we know that n minus 3 factorial can also be expanded. So this is the same thing as n factorial. It is also the same thing as writing n times n minus 1 times n minus 2 factorial. It is also the same thing as writing it as n times n minus 1 factorial. So we can express this number in that particular way, and we know what it means. So now it is clear here that 1 factorial is going to be equal to 1. So 1 factorial is equal to 1. But then the question is, what is 0 factorial?
It's 1.
So 0 factorial Yes, I can see hands. Benefit, Sivanda. You can ask your
Can you kindly
question.
mute,
Unmute yourself, please.
sir? Can you kindly block that you've raised? She's disturbing us, sir. That enemy of progress.
Please mute yourselves if you are not talking. You are enemies of progress. Okay, I guess it's now quiet. Right, so 0 factorial is actually defined as 1. So that's the definition. We will take 0 factorial to be 1. So that's about factorials. Of course, we can always find what a factorial of a particular number is. We can look at some examples just to illustrate this, but I'm sure this is clear. So here are some of the examples. Let's evaluate the following. So evaluate number 1, 10 factorial. Number 2, you have 12 factorial divided by okay, let's say 8 factorial. And then right, so here we are going to find the solution as follows. So we know that 10 factorial is 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8 times 9 and times 10. So the only thing that you need to do there is just to find what that number is. Can someone? Quickly, what is it? It is a very big number. I don't know how to find it. Here, I can ask you to use a calculator. Right, so.
So, sir, I've got a question. Sorry to hold you back.
Yes.
Yes, so I didn't really get you clearly on the factorials. So the factorials is just from the first number that you've been given. Okay, for example, you say 2 factorial. That means you just say 1 times 2. That's all right.
Sorry, I didn't get you clearly. Speak up a bit.
I'm saying for the factorials.
Yes.
If you've been given to say find, let's say 2 factorial. That means 2 factorial is just going to be 1 times 2, right?
Yes.
That's all.
So that is 2 factorial. Yes, 1 times 2, 3 factorial, 1 times 3, 1 times 2 times 3. So you multiply from 1 all the way to that particular number.
Okay. All right. Thank you.
All right. Any other question? Okay, so let's say go to 12 factorial divided by 8 factorial. Now, 12 factorial, of course, is 1 times 2 times 3 all the way up to 12. So I'm going to write this in this way. So that would be 12 times 11 times 10 times 9 times 8 factorial. So derivative 3, of course, I'll stop at that because, of course, we can write it in that particular way. Yeah. So we have 8 factorial, and then you are dividing by 8 factorial. So the whole idea of stopping at 8 factorial is because I've seen that we have 8 factorial in the denominator, so that this simplifies our calculation. So you can see that we can cancel those and just remain with 12 times 11 times 10 times 9 times 8. Right, so that, of course, you can find by multiplying. I don't know what it is, but the idea is how you should be able to manipulate the factorials. If you are dividing, then you can do what I have just done here. Is there any question?
Yes, sir.
Yes?
Can we have a situation whereby, let's say, 8 is the numerator and 12 is the denominator?
Do we have situations where?
Let's say the 8 is actually the numerator and 12 is the denominator.
Of course. And you can easily do it because it will just be the reciprocal of what you have now, which is just 1 over that number.
Okay.
Also.
Yes, yes.
So I have a question.
Yes, please.
Yeah, so there when it's cancelling, it's just the factorials that cancel. The 8 doesn't go entirely.
Doesn't go with.
No,
Hello?
the thing here is that 8 cancels, and then you just remain with 9, 10, 11, and 12. So those are the only the number figures that was supposed to remain with.
Oh, I'm not sure if I'm getting your question, but what we have now is a situation like this. If this is A, so this is just A over 8 factorial. So in this case, we are dividing. 8 factorial is the same. So we can simply cancel it and remain with the A. Even if you were to expand it, you can expand it, but still more, you still have to cancel them out because there will be common factors in both the numerator and the denominator. So in this case, 8 factorial is a common factor which we can divide through. I hope that answers your question.
So,
Okay. If there is no any other question, we can move on.
Sir, before we move on,
Yes.
yeah, I'm still not clear on this one. I get the fact that the common factors must cancel each other out, but where the 8 still remains, that's why I want to get clarity. On the other side, it's here, after cancelling,
I see.
times 12 times 11 times 10 times 9 times 8.
I don't know why I've left the 8 there.
Oh,
So, and the answer is supposed to be 118080, not 95040, if I'm not mistaken.
Yes. The answer is 1188.
Okay, so I've still where you were asking. 11 what?
118080.
1188.
Yes, zero
and
last.
Okay, so I didn't get the question earlier. Now I've seen what you were asking. So yes, because you have cancelled out 8 factorial, so in this case, you just remain with 12 times 11 times 10 times 9. Okay, so the next now, how do we write a number in factorial form? So let's look at the following example. I'll call it example number 2. So write in factorial form. So let's write in factorial form the following. So we have 96 times 97 times 98, 99 times 100. The next one is 9 times 8 times 7 . Oh, my computer is about to break. Oh. Right, so times 7 times 6. Then divide by 4 times 3 times 2. Right, so for us to be able to see what we have, so you see that here in number 1, we should have 100 factorial. So this number in factorial form, which is 96 times 97, 98, so I'm saying that this should have 100 factorial, but then we do not have on this expression 95 factorial. So in that case, then the 95 factorial is in the denominator. So, like you have seen from the previous example here, where we have 12 factorial over 8 factorial, we just have 12 times 11 times 9 times 8. So it means that in this case, we had 100 factorial, but then we are going all the way up to 96. It means that 95 is in the denominator. Is there any question on this one? Okay. Then we can go to the next one. here we have 9 times 8 times 7 times 2. Then you divide by 4 times 3 times 2. Okay, so we can see that here we may think of 9 factorial. So we may think of 9 factorial, and then we have a 5 factorial not part of this expression in the numerator. And then looking at the denominator, you also have 4 times 3 times 2, which is actually 4 factorial. But then the question is, how do we write this in factorial form? I want first of all to ask you, is there anyone who can try to tell us how this is going to be in factorial form? I'll give you 2 minutes because we have 8 minutes, so I'll use the remaining to finish up.
Maybe
Yes.
maybe 9 factorial
9 factorial.
divided by
Yes.
5 factorial times 4 factorial.
Times 4 factorial. Okay. So, is there any other answer? Messi, you want to say something?
Sir, I wanted to say the same thing.
Okay. So, this is now, according to what you have said, 9 factorial divided by 5 factorial, because we have seen that in the numerator, there is no 5 factorial, and the denominator still has 4 factorial. Of course, sometimes we don't write it times 1 because it doesn't change anything. So in this case, then that is what we are going to get. So you have 9 factorial over 5 factorial times 4 factorial. So that's how you can write numbers in factorial form. Whichever you are given, you should be able to work out what. Is there any question? Yes, there is a Zoom user.
Sir, a question.
Yes, Zoom user. Why do you have Zoom user, not your name?
Sir, just for this link
ahead.
when it was already. So what if we say 4 8 divided by 4, then we'll have a 2 there. Then 3 divided by 9, we'll have a 3. Then we also divide 2 into 6, so that we reduce the numbers. Then we just multiply. Is the answer going to be different? And is this the wrong approach?
Yes, so in that case, you'll be answering a different question, because here we are not simplifying. We are just writing the given number in factorial form. If we ask to simplify, of course, yes, we can simplify. So you'd be answering a wrong question.
All right, sir.
Kondwani?
Yes, sir. I had a question concerning the expansion. So what if looking at the same factorial that we have, can we write it as since we just count these numbers that are here, and then we just say n open bracket n minus 1 over the certain number that's here down here.
You are going ahead of us. So wait for the afternoon.
All right, sir.
Okay, so if there are no more questions, I think we can end here. I want to say that we will meet in the afternoon. We want to follow the timetable so that we don't have a clash with the other courses who want to also have a class with you. So we'll try to stick to the timetable, but if we have to go beyond the timetable like we have done, we'll always consult in case you are not free or you are free. So let's meet at 16 hours if it is possible. We can also use maybe 1 hour, 30 minutes if you are free, but if not, then we just use the first hour. I wanted to try in the afternoon to use the blue button, big blue button, so that we can accommodate more people, because I'm sure there are a number of them that couldn't join because of the limit that is there in Zoom. So let's say I posted the link on the Moodle. So you see where it says Group F lecture. So if you click there, then it will take you to the particular page where we can have a class. So let's try that. If that fails, then we can come back to Zoom. So let's try to meet at 16. Have a great day. See you later.
Ooh.